Hi, everyone. Thank you for joining today's webinar, Charting a Path to SD-WAN Operations. I'm Monique Lucy, Director of Product Marketing here at LiveAction, and I will be your moderator for today. I have just a couple of housekeeping items to touch on before we get started, so please feel free to ask questions during the session using the chat or Q&A panel on the right-hand side. And this session is being recorded, and we will post the recording to the LiveAction website in a few days, and it will be located in the resources menu under our on-demand webinars. If this is your first time joining a LiveAction webinar, welcome. I just want to make a quick introduction to LiveAction's network performance management solutions. Our solutions enable network teams to achieve operational and performance excellence in support of the success of the business. With LiveAction, network management teams are able to improve application performance, accelerate troubleshooting, manage their network readiness, deliver major IT initiatives, and perform advanced reporting and analysis. On our panel today, I'm joined by Seamus McGillicuddy, Vice President, Enterprise Management Associates, and David Azumo, Principal Technical Marketing Engineer here at LiveAction. Welcome, everyone, and thank you for being with us today. Seamus and David, please go ahead and introduce yourselves and give us a bit about your background.
Thank you, Monique. My name is Seamus McGillicuddy. I'm the Vice President of Research at Enterprise Management Associates. I've been running the network management practice at EMA for about 6 years, with a focus on wide area network transformation, data center network transformation, multi-cloud networking, all kinds of stuff. Anything that has to do with an enterprise changing its network architecture, engineering, operations practices, I investigate with my research. That's my introduction. Thank you.
Hey everyone, thank you so much for joining us. My name is David Azumo. I'm a principal engineer in technical marketing. I've been with the company for quite some time and was very happy to see how LiveAction continues to advance in the network performance monitoring space. I lead the technical partnerships from a technical perspective. So I work a lot with our partners like Cisco, Gigamon, and various others to provide a lot more visibility for these partners in the LiveAction product. So looking forward to the discussion today.
Thank you both so much. So before we go ahead and dive into Seamus's research, I'll just give you a quick overview of what we will cover today. So as we mentioned, Seamus will dive into the research that he's done around the topic of SD-WAN. And then following that, David will give a live demonstration of LiveAction solutions. So with that, I will turn it over to Seamus.
Okay, thank you. Let me just advance to my portion of the presentation. My presentation is, I believe the title of this webinar, I can't remember exactly, but yes, it's about charting a path towards successful software-defined WAN operations. And this presentation is based on market research that I conducted recently on wide area network transformation. We took a deep look at what enterprises in North America and Europe are doing with hybrid WAN, that is introducing internet connectivity to their WAN architecture, SD-WAN, secure access service edge, and other types of technologies, how they're implementing, how they're operationalizing, how they're securing, all of that, what kinds of challenges they run into, and so forth. So this research is based on a survey of more than 300 IT professionals with direct engagement with their organization's WAN infrastructure. It was conducted in August and September of last year, and the report itself was published in January. So it's pretty much brand new research. With that in mind, the agenda of my research, my presentation will fall 3 general areas. The first is just looking at the so-called WAN revolution, where I'll examine the hybridization of the WAN today, and also the movement towards SD-WAN adoption to support and enable hybrid WAN. Then I will cover the general operational challenges that enterprises tell us they're encountering when they make these changes, and then I'll try to help paint a picture of how you can move forward with a successful approach to SD-WAN operations. It's not just about adopting SD-WAN and using the native monitoring capabilities that those solutions offer. There's more to it than that. So first up, the WAN revolution, hybrid networks and SD-WAN. Our survey of 300 enterprises found that 99% of them are adding internet connectivity to their overall WAN architecture. And I think in the early days of SD-WAN adoption, there was a lot of discussion of MPLS going away and the internet becoming the new WAN. It's not really proceeding in that way, at least not yet. Maybe someday, but of the 99% of enterprises who told us that they are incorporating the internet into their overall architecture, 54% said they're making no change to their managed WAN services footprint. You know, the MPLS network is not being altered in any way. They are supplementing the internet, supplementing the existing MPLS footprint with internet connectivity. Only 17% said they're actually retiring MPLS for the most part, and almost a quarter of them said they're reducing overall MPLS investment, reducing maybe the number of links or the amount of bandwidth that they have, but they're not getting rid of it entirely. And as a small number said that their MPLS footprint was never significant to begin with. There's probably a lot of chain restaurants and things like that. Why are they hybridizing the WAN? Why would you might be thinking about it if you're on this webinar? The top three drivers are on the left. Number one, connectivity to the cloud. You're going to use the internet to go direct from your remote sites into the cloud. We see a lot of enterprises getting into like a full mesh network type of situation where they want to be able to get all the remote sites into the cloud as quickly as possible. No more hairpinning traffic that's headed toward the cloud through a central data center. They need to enable that internet connectivity to support direct cloud access. That opens up a whole can of worms that we can cover later, but another big piece, network flexibility. They want to be able to do moves, adds, and changes more easily, and the MPLS networks are just not flexible in the same way. Higher bandwidth requirements. MPLS is expensive. It's also bandwidth constrained in general. It's kind of hard to ramp up overall bandwidth as much with the MPLS network than it is with the internet networks that you have in the same areas. There's some places where MPLS bandwidth services just do not scale up to the level you might want, especially when you got a lot of real-time application traffic you need to support. You might need to supplement with the internet. 92% of enterprises actually report that WAN performance improves after they hybridize the network. 39% described it as significant improvements in performance. So how do they do that? How do they actually go from MPLS networks that have an SLA attached to them to the public open internet net? How does performance actually improve? Well, they're adopting SD-WAN. SD-WAN solutions enable hybrid connectivity. They have integrated security usually in the SD-WAN architecture, which takes away some concerns about the risk associated with using the open internet. They enable the cloud on-ramps that you might want to implement if you're driven by cloud connectivity, that you can more securely connect into the cloud. And they offer central control and visibility through the SD-WAN controllers, management consoles that are offered that give you sort of global control and insight into your WAN. On the left, you see where people are with this technology. 98% are engaged in some way with SD-WAN, which is not surprising since 99% of them are engaged with hybridizing their WAN with the internet connectivity, as the earlier pie chart showed you. 37% have fully implemented. That represents a pretty significant increase from 2 years ago. The last time I asked this question, when I think about 22% had fully implemented. And then 45% are currently implementing a solution. So a lot of activity right now. In fact, I've seen evidence that a lot of enterprises are actually on their second SD-WAN implementation right now, because a lot of them claim to have more than one vendor in their network, which means they're slowly transitioning to their next vendor. All right, so the operations challenge of hybrid WAN and SD-WAN operations in general. First off, when you do hybridize the WAN, there are some issues that you're going to be concerned about from an operational perspective. First off, almost a third of enterprises say that it's really hard to manage multiple ISP relationships. You might have had like one strategic provider that handled all of your MPLS connectivity on a global basis, or at least on a continental basis. And once you start using ISPs, there might be a lot more business relationships you have to manage, a lot more specification of requirements and requests for proposals, renegotiations, all kinds of stuff. You need to be able to scale up your team's ability to manage those relationships. That's not something you can really fix with SD-WAN. Security risk is something you can possibly address with SD-WAN. I mentioned a lot of enterprises are interested in SD-WAN because of its ability to integrate security into the network architecture, and that's something that a lot of enterprises get concerned about when they add the internet to their architecture. Application performance, can you enforce quality of service on your new hybrid network, and do you have the tools to see when that quality of service is insufficient? Inconsistent quality of ISPs kind of gets back to the issue of managing multiple relationships. You also have a lot of ISPs that have different types of performance baselines that you're going to encounter. You might find it more difficult to monitor and troubleshoot ISPs when they tend to have different levels of quality. And then inconsistent global performance. If you got some sites that are really far away from each other that need to communicate over the internet, the global internet backbone might become an issue that you need to compensate for with your visibility and your SD-WAN architecture. So, can SD-WAN's native monitoring close the operations gap? It's been a very big selling point for a while that native monitoring in an SD-WAN solution is really useful. And it is the #3 most important SD-WAN product capability, according to our research. Only hybrid connectivity, that is load balancing different network connections at a site and doing some steering across them. Only that and integrated security are more important to buyers. But not everyone thinks that native visibility is essential. For instance, it's not necessarily a best practice to focus on that capability when you are implementing SD-WAN. Enterprises that told us that they're less successful with SD-WAN overall were less likely to say that the native monitoring capability is critical to them. Only 27% versus 36% of the overall survey that we did. Network engineers are less interested in it, which tells you they're probably relying on traditional network engineering tools to give them answers to certain things that they might be investigating rather than the native monitoring console. Information security people are very interested, which means it might be something they go to answer questions when they're investigating something they saw in their own tool set. Now, 65% of enterprises told us that they have some sort of significant issue with SD-WAN's native visibility capabilities. You see at the top of this bar chart, 35% say none of the above. We have no significant problems with our native SD-WAN monitoring. That's actually a pretty high number. So it's nice to see 35% of people are really happy, but then you see all these other issues that are pretty significant. 30% say they have limited or no visibility into the WAN underlay. So, the SD-WAN solution gives you really good visibility into the tunnels it creates in an overlay, that it builds over the physical network, you know, but when it comes to time to like try to figure out what's going on with the ISP or the MLS provider, SD-WAN has few answers to give you. Also, a lot of SD-WAN solutions are not giving adequate visibility into application performance and application flows. Maybe they are not very good at identifying, classifying, and monitoring individual applications. A lot of SD-WAN vendors promote that capability, but some of them are not quite as good as you might think they are. Data collection lacks sufficient granularity is another big issue. You might want to collect data at a higher rate than they're willing to generate. If you turn it up, if you start collecting data at lower intervals, you might see a degradation in performance of that solution. We've seen that in our research before. And then a lot of SD-WAN vendors are software centric. They deliver off-the-shelf hardware to you, but most of their R&D is in the software that runs on the hardware, which means that they may not do a very good job of providing you with operational insight into that hardware. You know, what's going on an interface level, what's going on with memory on that device. You might need some other source for that. And then data formatting and summarization of data, no drill downs into raw data statistics is an issue for many. You see at the bottom here, Network Operations Center staff, 62% of them said they saw no significant challenges versus the 35% of the overall survey. What's that tell you? Most of the people working in a NOC are looking in the SD-WAN console and they see what they need to see. If they don't see what they need to see, they escalate. And then on the right, you see who gets that escalation. Network engineers, they don't feel the same way as the NOC staff. In fact, 63% of them said that they see issues with WAN underlay visibility. They are not happy with the WAN underlay visibility they're getting out of an SD-WAN monitoring capability. So what's that mean? They need a network engineering tool, network performance monitoring solution that can give answers to those questions. Also, they're really not happy with data collection granularity. So they need more data at shorter intervals, and the SD-WAN solution might not be capable of providing that without crashing. So what's the path forward for SD-WAN operations? First, here are the visibility priorities for hybrid WAN underlays. We asked enterprises to tell us what kind of internet metrics they find useful for monitoring and managing the internet components of their overall hybrid WAN architecture. And you see a majority of them picked out two, end-to-end loss latency and jitter across internet paths. That's something that an SD-WAN solution might be able to report to you, but you probably also have tools that are already really good at doing that. And you need to make sure they can do that with your SD-WAN solution in place. Internet and ISP outage reports is another big one that they might be using. And then DNS availability and resolution times looks like it's pretty important. Less of a priority, hop by hop analysis of those performance metrics, CDN edge availability and response times, and BGP routing changes, but still pretty significant number of them. I mean, almost 1 in 3, more than a quarter, are really focused on BGP routing changes. So that's something that you may really need in the future. And then when you look at like your traditional tool set and like what you're using for network performance management, like what kinds of metrics collected by those tools are you likely to need? These are the ones that are most important according to these people that we surveyed. They're really interested in increasing their use of synthetic traffic monitoring. They're really interested in doing a lot of routing data collection. There's a lot of them are thinking about endpoint transaction monitoring, which means like endpoint monitoring tools, which might be like a new area for a lot of network operations professionals to get into. And network flow records, so just turning more to net flow or IP fix than you have in the past to deal with this hybrid network. Now, when you get up a layer to the SD-WAN implementation on top of the hybrid network, you're going to want to have well, first of all, chances are you're going to have a managed SD-WAN solution. Our research has shown that enterprises have taken a hard turn towards consuming SD-WAN as a managed service in recent years. A couple, 3-4 years ago, enterprises are kind of split on whether they're going to consume SD-WAN as a managed service or do the implementation on their own, just like buy the solution from an SD-WAN vendor, put all the devices in place, and design, provision the network, build all the site-to-site tunnels, and allows people doing full mesh. It became quite a headache, and as you can see here, transforming your network is best done for a lot of these guys with a managed service, whether you're buying that from your SD-WAN vendor directly and making them a managed service provider for you, or getting it from your network service provider like an AT&T, Verizon, Lumen, whatever. Or if you're working with like an independent managed service provider that's offering an SD-WAN service, your chances are 62% of these people said that's their preference. 12% said they still prefer the DIY approach to SD-WAN, and a little over a quarter of them said they're still figuring out what their preference is as they move forward. But although so many of them are pursuing a managed service as a procurement and operations preference, they want a hybrid operations model. You see on the right, what their SD-WAN operations preference is. 63% say they want a hybrid approach where both their internal network operations team and their external MSP share responsibility for monitoring, troubleshooting, moves, adds, changes, what have you. Only 16% want to outsource that completely to an MSP, which is almost an inverse of what you see with the procurement preferences. And then only 17% want to internally manage operations completely on their own. They want to put together some sort of agreement with their service provider to share operations, and that means that their existing internal network operations tool set and also the MSP tool set is probably going to need to integrate with their SD-WAN solution. And that's why we find in our research that third-party network performance management tools are essential to SD-WAN operations. Network performance management is pervasive in SD-WAN. 92% of enterprises say they are doing this or planning to do this, where they're going to use their existing network operations tools, their performance management solutions, to monitor the SD-WAN. Only 9% say no. You see 41% say it's critical versus 51% say it's only helpful. Now on the right, you see best practice. It's 51% of successful SD-WAN project owners or people with involvement in SD-WAN project told us that they consider third-party NPM monitoring of SD-WAN to be critical. That is an indication of a possible best practice. Now it's also more often critical to IT executives by a slight margin, but also network engineers and security professionals. That tells you the people that are getting escalations from the NOC and from other places are more likely to need that third-party monitoring. You see, it's less likely to be critical for people who identify themselves as network operations center staff. Only 18% of them felt as critical versus 41% of the overall market. So, like I said earlier, if you're working in a NOC and your process is to try to do tier 1, maybe tier 2 response to issues, yeah, chances are you're happy with the native monitoring console that your SD-WAN provider gives you. But after that, tier 2, tier 3, and beyond response, whether it's information security, network engineering, application owners, help desk technicians, they all might need a tool that can monitor SD-WAN from a third-party perspective, and network performance management is the key piece of that, I think. So how do you do it? What do you expect to do to get that third-party monitoring of your SD-WAN implemented? Well, 56% said that they integrated their tools on their own with their SD-WAN solution. Maybe it was just a question of turning on, configuring their SD-WAN solution to generate net flow or something, and that was going to be just fine. 48% said they relied on vendors to integrate tools. 13% said that their tools supported SD-WAN out of the box. You see that those three numbers do not add up to 100%. It's higher. That's because a lot of them, a handful of them, about 9% of them selected more than one, which tells you they're doing a multi-pronged approach to this. They've probably got more than one tool vendor that they're working with to get SD-WAN visibility. Two network performance management solutions, maybe flow-based, maybe an SNMP-based monitoring solution. They need help though. 48%, only 48%, less than half say they're fully satisfied with their ability to monitor SD-WAN with their third-party tools. These fully satisfied people are more likely to be consumers of SD-WAN managed services, which tells you that the managed service provider probably helped them a lot. 48% say they see room for improvement in their ability to monitor SD-WAN with their third-party performance management solution. And this correlated with individuals who told us their SD-WAN projects were less successful, either somewhat successful with a need for improvement or unsuccessful. So what's your to-do list? This is my last slide, by the way. You want to develop a hybrid ops model with your SD-WAN provider if you're using a managed service, and the chances are if you're using SD-WAN as a managed service, they'll help you get your tools lined up properly with your SD-WAN solution. You want to stretch beyond native SD-WAN monitoring features. Your NOC will lean on the SD-WAN console and maybe a little too much, maybe even encourage them not to lean on it too much so that they can escalate fewer things to your engineers. Your tier 3 engineers are definitely going to need deeper visibility with a network performance management solution. While you're thinking about how you're going to get that third-party monitoring, think about your data that you're going to use to get that visibility. As we said, there's a lot of different data in there, including endpoint monitoring. So think about how you might want to diverse your data collection to make sure that the third-party tools do give you the insight you need. Internet metrics, you might want to expand your use of internet metrics, for instance, like end-to-end loss latency and jitter across paths, things like that. And then push your NPM tool vendor and your SD-WAN vendor to integrate and work well together, and maybe even possibly support that integration professionally. And with that, I'm going to turn it over to the live action game for their part of the presentation.
Great, thank you very much, Seamus. Go ahead and share my screen. There we go. So LiveNX is very well known for our visual analytics for situational awareness. And one of the main goals that we have within LiveAction is to help recreate the mental model of the network engineer. So what we did was we created this engineering console, the THIC client, to be able to really understand hop by hop throughout the network where that traffic is going. So let me help you get your bearings on what you're seeing here. We have multiple sites, a site out in San Jose, as well as a data center in RTP, so 2 data centers within this environment. And they're interconnected by 2 service providers, an MPLS provider, as well as an internet provider. And they provide connectivity down to the 2 branches, one in Miami down below on the left, and then also Chicago on the right-hand side. So as you can see, LiveNX is very dynamic in nature. You can move things around. And again, this is to help you recreate the mental model of the way that you think about the network. Now, when network engineers or network administrators design a network or work on their network environments, they typically go to a whiteboard or they go to a Visio diagram and they start laying out the various devices and then interconnect them. This is really, you can consider LiveNX as a dynamic whiteboard of sorts. So I'm going to zoom in to this topology just to help you understand what's happening a little bit further. You can zoom in using the scroll button on your mouse, or you can use these little magnifying glasses in the upper left-hand corner. So in this case, this big circle is a WAN edge router. These big circles in LiveNX represent any type of network device. It could be a WAN router, it could be a switch, it could be a firewall, or various other types of devices within the environment. So in this case, it's a WAN router. Now the little circles inside represent interfaces. So notice that this is Gigabit Ethernet 01, Gigabit Ethernet 02. These are your WAN interfaces connecting off to the various service providers. The top portion of these little circles, these interface circles, represent ingress bandwidth, and the bottom portion egress bandwidth. So very quickly and easily, you're able to get your bearings and understand a little bit more about the topology that we're working with. Now I'll zoom out just a little bit here, and notice that we also have all these pretty colored lines over the top. Now these lines of various colors represent the data traffic, the user traffic or application traffic running across the system. So you can see various types of traffic as the legend brings out in the lower left-hand corner for internet traffic, network management, enterprise applications, voice, and so forth, and they're colored accordingly. Now, the nice thing is you can track these application flows end-to-end across the system, going from one particular site out to the various service provider links that you have into the data center. Likewise, you can double click on one of these devices, and I just double clicked on the Chicago router, and we're going to bring you into the real-time view for this router. Now, in this case, we're looking at the real-time conversations. And from a NetFlow or an IP fix perspective, you're able to see all these conversations, the IP addresses, the port numbers, and so forth. But likewise, many of these these SD-WAN vendors provide DPI as well, so deep packet inspection, to understand the exact application that these conversations are using, right? Or which applications those users are accessing. So we identify applications like SIP or YouTube, or applications like SAP or Hulu or Citrix and so forth. So this helps you to really identify where those applications are going, right? And then likewise, we have a playback capability. So you can think of this playback capability kind of like a NetFlow or an IP fix DVR of sorts. So just as if you're watching a television in the old days, actually maybe a few decades ago, you may have a DVR or record that television show of interest, and you can go back and watch it later. So likewise here, we have that same type of capability for DVR type playback for NetFlow or various types of conversations. So for example, I can go back in time, and then I can look at a specific time period and simply click play. And I'm going to play back all of those conversations as if I'm sitting on the console live. Right? And then you can interact with this to really understand which applications are taking various paths. So I'm going to go ahead and close this out. And one more piece that I'd like to bring out is also being able to look and drill down on a specific application. So for example, if you're troubleshooting voice over IP, you can simply type in a search for looking for that application, voice over IP, and then this is kind of like a Google search for NetFlow of sorts. So I'll go ahead and press enter, and we'll query the back end for all of the voice over IP traffic that we see. So over this time period, we can see that voice took various paths. It's going between these various sites, specifically from data center in San Jose down to my various branches in Chicago and Miami. And over this time period, it's taking two paths, both MPLS as well as internet. So for this time period in particular, SD-WAN is load balancing that traffic, or based off of policy, it's moving that traffic from one provider to the next, perhaps because of a performance issue. Now, let's change gears and let's move over to our operations dashboard. This engineering console that we're looking at first really helps us to understand the raw constructs. We're looking at the IP fix flow data, NetFlow, SNMP for site and device health, and so forth. But to really operationalize SD-WAN, we're going to switch gears and go into our operations dashboard. And now we're looking at the same LiveNX system, but from the operations perspective. As you log in, you're presented with this overview page to understand the sites, the devices, the various interfaces, along with all of the alerts that are coming in. Now, these alerts could be generated by LiveNX based off of what we see from the various telemetry that we pull in, or also it could be alerts from the SD-WAN controller itself. And likewise, from a network performance monitoring scenario, you may want to interact further with these dashboards. So for example, if you want to look further at a particular site, maybe that data center in San Jose, you can simply click on Site San Jose, apply that filter, and this whole dashboard will converge around that site of interest. So these are the devices that are tied to San Jose, along with the interfaces and the relevant alerts. Now, you can drill in further to that site to get more detail. So I'm going to go ahead and click on Site San Jose. And that will automatically bring up the site view within LiveNX. And we provide a visual representation on the right-hand side of the various edges that you have, the various network devices in that site, the service provider connections that it has, along with details about this site, including the service provider bandwidth, both inbound as well as outbound. And notice, interestingly, that there's traffic that's moving from the MPLS provider to the internet provider and back again, specifically in the inbound as well as the outbound direction. We're going to dig into that a little bit further. Likewise, the applications that we're seeing inbound as well as outbound. So we see those applications that we noticed earlier, like voice over IP, RTP, SIP, YouTube, and so forth, along with the DSCP values for quality of service markings and the top conversations as well. Now, likewise, perhaps you may want to drill into specific applications. Earlier on the engineering console, we looked specifically at VoIP, so I'm going to do that same thing here. So I'll just type in VoIP into this search query for the application, and I'm going to drill down specifically on VoIP. So I'll click on that, and now we're looking specifically at that application, voice over IP, for the San Jose site. And notice that on the right hand, we see that visual representation for voice over IP. We're seeing that it's taking multiple paths, both the MPLS as well as the internet path, and that traffic for voice is going off to our various sites that we see here, a branch in Miami as well as in Chicago. We additionally provide more information about the top conversations for voice over IP down below. But now let's dig in specifically to Cisco SD-WAN as an example, where we can better understand exactly what's happening from an SD-WAN perspective. Now, in this case, we're going to be talking specifically around Cisco SD-WAN, but for any SD-WAN vendor that especially supports IPFix or NetFlow, we can provide this type of visibility. So notice that we see the various sites that we're looking at earlier. The two data center sites in San Jose and RTP, along with Chicago and Miami are two branches. And we laid this out on a geotopology view. Now, notice again, we see those pretty colored lines, and they represent the application traffic over the top between these various sites, along with that legend in the lower left-hand corner. So notice, if you want to identify where all that voice over IP traffic is going across the topology, you can simply click on the legend, voice over IP, down in the lower left-hand corner, and we're going to show you where that VoIP traffic is traversing the network. Likewise, if you're interested in Office 365, simply click on that, and we can see where that traffic is going, or Skype, or Netflix, or SIP, or various other types of applications. Now, notice also, we can identify the policy, the application-aware routing policy also. So I'll do that by clicking on this button here. So in this case, we make a query to the controller via API, and we're pulling down that policy. So now this helps us get our bearings as far as how the policy is set up. So in this case, there's two classes, one for web SLA or web traffic, and another for voice and video. So notice in particular, voice and video has a threshold of 50 milliseconds for latency. Now, according to this policy, voice over IP is going to prefer the MPLS path, and then the backup path is going to be business internet. So again, this policy helps us to get our bearings, and then with visual analytics within LiveNX, we're able to verify this policy a bit further. So I'm going to close that off. And notice also that we have dashed lines going from site to site. Now, these dashed lines are representative of the aggregate tunnel statistics. So I'm going to go ahead and click on that. And notice as we bring up these tunnels from Chicago to San Jose, we're going to be able to identify specifically the performance per service provider along with the SLA classes. So notice here, we read in the various SLA classes for voice and video along with web SLA. And notice that everything is green for the business internet path. Now, why is that? Well, peak jitter is only 2 milliseconds, very little loss, very little latency as well. But notice as I mouse over the MPLS path that there is a good amount of latency, right? Over 200 milliseconds of latency for this time period that we're looking at. Notice also that there's 10% packet loss, but it's showing up as green. Now, the reason why 10% packet loss is green and latency is red is because LiveNX really understands the policy, right? And if you recall, the policy for voice and video specifically called out latency. It didn't have a measurement or a threshold for loss. So even though you're having 10% packet loss in this scenario, it's not crossing that threshold for SD-WAN. Right? So again, LiveNX, via our taking advantage of northbound API connections to the controller, we're able to understand more details about the policy. So let's dig in further. Let's see why there was this high latency, and why we needed to traditionally be able to move traffic from one provider to the next. So we can do that by clicking on this little button here. And in 3 button clicks, we're going to go ahead and troubleshoot a brownout scenario. Why did voice over IP and various other applications move from one provider to the next? So this is that first button click where we see the overall view of the various classes and the service provider performance. So I'm going to click on this to drill down to that site-to-site view. So I'll click on that there. And we're drilling down now into a site-to-site Sankey diagram. And again, we have that same context. We're looking specifically at San Jose to Chicago. If you wanted, you can click on this little button here, switch direction, and we'll go and flip the Sankey diagram around and look at traffic from Chicago to San Jose. But in this case, let's look at the data center to that remote site, Chicago. We lay out from left to right the applications of interest flowing from site to site, how those applications are segmented from a service VPN or VRF perspective. And in this case, we only have one VRF, VRF 10. Then the DSCP or quality of service markings for those applications, along with the service provider path these applications are taking. And then finally, on the far right, the status of those service providers on a per SLA class basis. Now, the user is able to click play, and we'll play back and animate this traffic. And you can see this traffic going from end to end, site to site, as it takes various service provider paths. And then again, you notice the various statuses for those service providers over time. Now, I'll reset this animation. Now, this is that second button click. You can get an overall view of how these applications are traversing the network, taking the various service provider paths from an SD-WAN perspective. But now the third button click is I really need to get more details. I need to know exactly when that traffic was on a provider, and then when that threshold crossing issue occurred from a performance perspective. So the way that we'll do that is I'll drill down into each of these service providers. So first off, I'm going to click on the MPLS provider. And now we're presented with the details. What's happening site to site on this MPLS provider? Notice, again, we have that same context. We're looking at San Jose to Chicago, and at this point on the MPLS service provider. So here's all the application traffic going from site to site. And notice, again, we see VoIP, RTP, Citrix, and so forth. Here's the QoS markings, along with the top conversations. But notice as I scroll down further, now we get more details about the performance of that tunnel from San Jose to Chicago. So here's the jitter over time. But notice that the jitter value of 22 milliseconds at a peak is really normal for this scenario, according to the policy. Likewise, I'll scroll down further and we see up to 10% packet loss at this point in time. But again, the packet loss is showing up as normal. And again, we discussed that earlier. That's based off of the policy from the SD-WAN controller. But now the real culprit here is delay. So here's when we have high delay, up to 200 milliseconds or more of delay. And notice as I scroll to the right, this is really a critical issue between these two sites, over 200 milliseconds of delay. Now, when we have that high delay, notice as I scroll to the top, that's really when that traffic falls off of the MPLS provider. Now, where does that traffic go? Well, according to the policy, it's supposed to flip over to the business internet path. So as I look at the business internet traffic, notice that it's an exact mirror image between business internet and MPLS, right? So in this case, SD-WAN is doing its job. It's identifying when there's a critical issue. In this case, there's high delay. It recognized that brownout scenario and then move that traffic away from the MPLS provider here over to the business internet provider to make sure that the users have that very high quality of experience for the end users, specifically for critical applications like voice over IP, maybe Office 365, or various other types of applications. So this is just a quick overview of LiveNX and how we're able to provide you with unparalleled visibility for your network across your various sites, and especially for SD-WAN. So with that, I'll turn it back over to Monique.
Thank you both so much, Seamus and David. So today you've heard about the impacts of hybrid networks and SD-WAN, and you've learned a bit about how LiveAction can help address some of these key challenges. So here's just a quick summary of how LiveAction is different from other network management tools. We provide end-to-end network visibility in a single pane of glass across the entire network, including campus, branch, data center, public cloud, WAN, and SD-WAN. And we're also vendor agnostic with the broadest support of key network vendors and offer the broadest telemetry, including NetFlow, Packet, SNMP, API, IPFix. We have an enterprise scale platform with real-time and historical monitoring without compromise. And we provide unmatched data fidelity and the finest level of granularity with predictive analytics to proactively identify, troubleshoot, and resolve network performance issues leveraging both ML and AI. So with that, I'm just going to pause here for a moment because I see that we've had some questions have come into the chat. Let's see. Here is one. Do you support VeloCloud SD-WAN?
Yes, I'll take that question. So yes, we are working with VMware VeloCloud, and we do support VeloCloud SD-WAN, specifically around their IPFix capability along with SNMP. The IPFix telemetry that we get from the VeloCloud Edge devices is actually quite interesting. They provide a lot of details about the conversations, the applications, and so forth, but also we can get additional details about performance of tunnels, as well as even performance of the applications themselves. So we're continuing to work on that integration with VeloCloud and expand on our current integration via specifically IPFix, SNMP, and add additional capability even more in the future. Yeah, so thank you for that question.
Thanks, David. So here's another question. I think, Seamus, this one might be for you. How do you recommend enterprises mitigate the risk that hybrid WAN introduces to application performance?
First thing you want to do is baseline your existing performance before you even introduce a hybrid architecture. So get a sense of how your network is performing in its legacy state, what kinds of applications are used, how they're used, what kinds of patterns you see, what user expectations might be. Using a solution like LiveAction or another network performance management solution can help you with that. And then that will help you not only understand, the expectations that the business has for your network overall, but it'll also help you figure out which applications need to be protected as you move to a hybrid network. And then as you adopt an SD-WAN solution, it'll help you, identify the applications that need a certain level of quality of service from that SD-WAN overlay. And you can use your network performance management solution to validate that the applications are moving across the network appropriately, have the right quality of service, and so forth. For instance, if you adopt a hybrid network, there might be some applications that you just you do not want on the internet. You want to, if you're going to maintain an MPLS footprint, maybe there's certain applications you want to keep sending onto that network with its SLA. And then there might be other applications that are more best effort, and you want to dump all of those onto the internet as much as possible to protect those applications. So using an NPM solution to sort of map that all out, get a good understanding of how your network works, and then transition over to that hybrid network and make sure it's all enforced properly on the hybrid network is a good first step.
Thank you, Seamus. I think we have time for one more question. David, this one is probably for you. How does LiveAction integrate with Cisco SD-WAN?
Yeah, thank you for that question. So for Cisco SD-WAN, we actually have quite a bit of integration within LiveNX. Seamus was talking a little bit about various types of telemetry in his presentation. We actually take in a tremendous amount of telemetry from the Cisco SD-WAN environments. So the basics like SNMP to the V-edges and C-edges to understand interface bandwidth, CPU memory, and so forth, along with IPFix to get that rich details for application awareness, conversations, and so forth. But we augment that with northbound API connections to vManage. So that gives us details about policy, tunnel performance, and so forth. So we actually have a lot of integration with Cisco SD-WAN. And in fact, we were working originally with the Viptela team even prior to the acquisition of Cisco. So many of our customers may be migrating from traditional Cisco WAN architectures, IWAN architectures to Cisco SD-WAN. Or various other types of SD-WAN vendors, and LiveNX can really help with those operational transitions. So thank you for that.
Thank you, David. That's great. So how can we help? You can get the full picture and insights for successful SD-WAN operations by checking out this WebEx or sharing it with other colleagues when the link becomes available in the next day or so. Or you could also request a one-on-one LiveNX demo session or download a free trial. And you certainly don't want to miss our next webinar slated for April around ensuring network readiness. Thanks so much for joining us today. Bye-bye.